Hi, everyone. My name is Samuel Dominguez. I am a former Summer Bridge to the Beach research scholar, also a former transfer student. And today I want to briefly talk to you about two research projects that I did upon transferring to Cal State Long Beach about 1 and 2 years ago. So the first research project I did was called Analyzing Heavy Civil Construction Equipment Emission Factors in Terms of Feasibility. This project was done through HSI STEM, uh, through a program called the Summer Bridge to the Beach Research Scholar Program. Basically, just in the summer before I transferred to Cal State Long Beach, I got paired up with faculty in the department I was transferring to, and whatever research they were doing, I was allowed to help them. So I got paired up with Dr. Kim, who's a professor of construction management. This is like the sister program of what I'm studying, civil engineering, and we did this project. The big picture of what this project means is basically there's a lot of equipment on construction sites that is not so great for the environment. They emit a lot of greenhouse gases and particulate matter, which contribute negatively to global warming and also our health. So we wanted to understand basically what are the main factors that contribute to emissions on construction sites. And we wanted to basically survey people on construction sites, particularly contractors and construction managers, on what are some easy ways that you could cut down on your emissions. That's it. For instance, one of the big ones was idling. You know how, like, when you're at a red light, your car is on, but it's not going? The same thing happens at construction sites. You have a lot of big equipment that is running and emitting a lot of horrible stuff for the environment, but it's not being used. And so we wanted to understand basically how feasible was it to stop doing that. If you could put a number on feasibility. The way we found this out was actually pretty cool. We used something called the analytic hierarchy process. To this day, I really find it interesting. Basically, we asked the participants of our survey, who are people in the industry and whatnot, we asked them to compare two factors of emissions on construction sites. And we would say basically like, if you had to say which one was easier to reduce emissions in, could you put a number on it? Could you say that, for instance, equipment configurations are 5 times more easy to change than equipment condition? Or else basically we compared every factor to factor to factor to factor. And what we were able to generate was a matrix of equations that said basically A is 5 times B, and B is 5 times D, and D is 6 times A, and so on and so forth. And so yeah, we got these matrices that were a little bit bigger than this. I think our average one was about 9 rows by 9 columns. And the crazy thing is, we were able to see if participants were being consistent in their answering, because we could take the matrix and compare it to a completely random matrix. And basically we'd see how random people were answering. Because it makes sense if you have a matrix like this where people say A is 5 times B and B is 2 times C, you would basically be able to figure out through logic the relationship between A and C, because you know the relationship between A and B and C. So at the end of the day, we could see, were these participants answering consistently? And if they weren't, then if they answered about 10% randomly, then we couldn't use the results in our project. One of the issues this presented, though, was that it made finding useful data really, really challenging, because the survey itself was really long, and I basically had to email 200 people just to take our survey. And when they finally did, a lot of them did not answer consistently. Probably they just kind of bubbled in the answers to be kind. Anyway, the results of the survey found that of the primary emission factors that we researched, equipment and maintenance was the most feasible to change in order to reduce emission factors. That kind of makes sense. Operating conditions was found to be the least. So that also makes sense because if you're on a construction site, you can't exactly change the conditions of the site to reduce emissions. Like for instance, one of the things that kind of counts against emissions is how many slopes there are on a site. So if a site is on a really steep slope, you can't change that. That's not within your control usually. And that's why the participants found it the least likely or the least able to change in order to reduce emissions. We also, including the level 1 primary emission factors, we also found level 2 secondary emission factors. You can call them subfactors. By the way, we found these through basically reading through a literature review. We looked at a bunch of articles that outlined the primary emission factors and the subfactors and whatnot. So if you look at this graph is basically just a more specific version of the previous graph we looked at. And so if you can see these three right here are the equipment conditions. I think, yeah, equipment maintenance. So these like the set of 3 columns right here represent the equipment maintenance. This was, the site conditions we talked about. So within the equipment maintenance, we found that the tire and tracks were the easiest to maintain. Basically, if the condition of your tires are not that great, your machine's not going to be that great. It's not going to run that efficiently, and it's consequently going to contribute more greenhouse gases and particulate matter. So if you can maintain the tire and track condition, then you can reduce emissions. And of all the people we surveyed, they said that it was most feasible for them to just maintain the tire and track conditions. And a bunch of other results I don't really remember too much. But yeah, the conclusions are along the lines of what I just said, that it's easier to maintain the equipment maintenance than anything to reduce emissions. But the issue with this research is that we need more people to take our survey. I think we must have had like 15 people who took our survey and like answered consistently. But it was a fun research project. The issue is you can't really say anything true. You can't say anything with any impact if you don't have enough people taking the study. You need at least 30 answers to say anything with any statistical significance. Let's go to the next one. So the next project I did, it was with the same PI as principal investigator. And it was, I think, a lot more challenging. I was only able to get in on this research project because the last research project was like a training ground for me. So this one was different. Basically, let me give you the title first. We called it Freight Demand Model for Southern California Freeways with Owner-Operated Truck Drivers. This research was not actually a model. The basic premise of it is throughout the country, there are commercial truck drivers, and then there are truck drivers who own and operate their own trucks. With the commercial truck driver, they will basically choose their own routes for themselves, or sorry, the company they work for will choose the routes for them. But an owner-operated truck driver is kind of at his or her whim to choose the routes. And we wanted to understand basically in a couple of freeways in Southern California, how did these owner operators, truck drivers, choose their routes? That was it. And We also wanted to understand the demand for a truck-only toll lane. You don't really see that too often in the States, but there are a couple examples. Truck-only toll lane is basically like a regular toll lane, except only trucks can go on it. There are a few advantages to a system like this, primarily that there's not going to be as much risk with the traffic. And since there'll be fewer passenger cars on the freeway, truck drivers might feel more comfortable on it, like they're not going to crush some other passenger car. And that's probably the main benefits. So to understand the demand for truck-only toll lanes and to understand how these truck drivers, the owner-operated truck drivers, we call them OOTDs, to understand how they choose their routes, we had to do a survey. The survey looked kind of like this. We would present the truck drivers with two scenarios, and one of the scenarios had no toll, and one of the scenarios had a toll, but it was a truck-only toll lane, and we asked them if they preferred this toll charge. The difference between the scenarios was usually speed, but some, well, actually, it was split between safety, speed, reliability, and oh man, what is it? One other. But we compared a number of factors. We also we asked them basically how much would they be willing to pay for such a toll. Even we presented a $5 toll charge, but if they said no, we wanted to know, would they pay $0, $2, $8, and so on and so forth. We wanted to understand how much they valued this option. So the issue, though, the funny thing with this type of survey, we used a survey program called Qualtrics, but it ended up being totally useless for us because when we tried to get a hold of these owner-operated truck drivers, it turns out a lot of them didn't have laptops, or they weren't even, there wasn't really a good place for them to take the survey while they were on the road. So instead, we had to actually make a paper survey. And since we are in Long Beach and the Port of Long Beach and Port of LA are so near to us, we just went ahead and surveyed them in person. This was pretty hard. We only got about 33 responses, something like that. But the results are basically that 75% of the time, truck drivers wanted to take the toll road, even though it costed them money. We also found that the truck drivers, they did not feel like they could charge their client to pay the toll. Only one guy actually thought he could get the client to pay the toll. That's a big deal because these guys operate their own trucks. It's really expensive for them. The tolls are really expensive for them. And basically, it used to be a really great business, but with all the regulations that have been thrown down on them, it's not really feasible for them to operate. But despite this, on average, 75% of the time, they chose to take the toll lane, whether it be because they preferred the added safety or the added reliability. They chose it. And yeah, let's see. I have not this poster in a long time. Let me just look at it for 1 sec. Actually, let me just pause this recording. So after reviewing this poster for just a minute, I think the most interesting finding of this research is that when you presented these truck drivers with the option for a toll lane, they almost, when it came down to reliability, they actually didn't care that much. In fact, it was so much more important for them that the route they chose was safe. That's something interesting to me. Anyway, I was able to present this poster at the SACNAS conference late last year, and that was a really good experience for me. I think I still need a lot of help presenting posters, though. This recording this is good practice, I think. But besides that, that's my research. Lark, I think, asked me to briefly touch on how the research kind of impacted me as I was searching for jobs. And to be honest, it really did. For one thing, all the professional development seminars I went through as a part of the Summer Bridge to the Beach program totally transformed me as a professional. And they really made me a little bit more serious about graduating and getting a job. But the second thing is that, as I was going through all the steps that the Summer Bridge to the Beach program suggested I do, like, working on my resume and going to job fairs, I actually ended up scoring an interview at a job fair through school. And I specifically remember during the interview, we talked about this research I did. And I explained the analytic hierarchy process to them, and they didn't really understand it, but they thought it was interesting. And they really liked that I could explain it and that I understood it. And a few days later, they offered me a job, and I accepted it. So as soon as I graduate, I think, like, I'm gonna take 2 weeks off, I think. But as soon as I graduate and 2 weeks later, I'll be working. And as a engineer to be, that gives me a lot of relief, to be honest, to not have to worry about getting a job after graduation. Anyway, thank you for listening.